Okay, Ken Leong, I would like to ask you, if I set a policy that you go on the road, you don't simply throw rubbish, then if you don't throw rubbish, I will give you a credit
Wow,
every day. What about that?
that sounds interesting.
Interesting.
But the credit, can I convert into cash?
Wow, convert to cash. Wow, very smart. You want to know more? Let's
That's
Sembang AIoT. Hello, very good afternoon, everyone.
After
CC
everyone.
Lee here.
Yeah, I'm Daniel.
Yeah, okay, and very happy to see you today. So we started a little bit late today. Yeah, if you missed this conversation at a very early stage, maybe we are going to talk about something related to cash and credit. Okay, yeah, you can watch back the front part, which I think very interesting. What is this cash and credit? So, yeah, if I ask you not to throw rubbish for the day on the road, if you can meet that, I give you a credit. I give you a point or star. But you're asking me whether the star can be, what is the use of a star, right?
Yeah.
No use, I can convert to cash. Wow, that is fantastic.
Yes.
Let's talk about this thing today. Yeah. So it is going to be about something related to our environment. Today, I think we have a two session. One part is not two parts lah. Yeah. One part we are talking about the carbon credit. Yeah, carbon credit, not the cash credit. Carbon credit. And then we want to connect back. The last week we were talking about smart building, smart energy. Yeah. So Ganel is going to share more about smart energy. But I think maybe that would be wonderful if, let's say, we can gather some of your inputs or get more of your feedback, in order to discuss about this topic. As you know, energy, smart energy, or ESG. Yeah, ESG. I think several sessions before we spoke about ESG. Of course, this topic is becoming more and more important. And then with the advance of this AI, things can be handled or can be managed differently, totally differently. So let's discuss about this one again. And then first of all, I would like to welcome you to join this Let's Sembang AIoT. Actually, the basic name for this session is Jom Let's Sembang AIoT. Yeah. So if you are watching this overseas, maybe you don't know what is this Sembang. Yeah, Sembang means what?
Sembang means talk.
Talk, chit chat. If you are in Indonesia, it's bicara lah. We are bicara. We are doing a bicara on this AIoT. Of course, this AIoT meaning a fusion between the AI and IoT. Yeah, that is a key thing. But of course, in most of the session that I share with some of this audience is that AI to us, AIoT meaning automation, AI, and also IoT. Yeah, there's an ingredient of automation inside. So as you know, we can't run away from automation. Anything that we are doing, of course, when we talk about industrial 4.0, automation is important, but it's actually it's a past. It's a past. Meaning Industry 4.3, 3.0 is supposed to be more automation. Yeah, but 4.0 we are talking about more autonomous. Autonomous meaning within the subsystem, they can transact things, they can do automatically things can be transacted automatically. That autonomous that we were talking about for the Industry 4.0. So let's go to our main key thing today. We talk about this carbon credit. Can we have just a picture lah? Yeah, just a picture. Okay, talking about this carbon credit. Yeah, I ask you about this carbon credit. What can you imagine from this carbon credit here? Very similar to what I asked you just now. Yeah.
Carbon credit. So if I didn't release a lot of carbon dioxide or carbon into the environment, then I get some credit.
Wow, that's very smart guess. Yeah, that is exactly what this carbon credit is all about. Because on the side, when you look at this carbon, a lot of people just say, what is this bloody carbon credit? Carbon also got credit, man. What is the carbon credit is all about? So, meaning there are some countries, especially in Europe, in America, in more developed country, so they set this a benchmark where it only selected few in several industry, not all. For example, power plant, for example, manufacturing. For example, some other buildings and so on. So these are the source of CO2 or carbon generator. Those are carbon generators. So from there, they will set a cap where if let's say you you emit less carbon, I will give you a credit. So how they quantify the carbon? So it depends on how they quantify the carbon. Okay, let's see. Yeah. So that means from here, what they are giving is this carbon credit. So meaning you emit less carbon, I will give you a coupon. I'll give you a coupon. Let's see. Okay, it's a coupon. You didn't emit so much, right? That is a reward that I can give it to you. You emit less pollution thing, I will give you a coupon. So this coupon you can keep. You can keep. So how do they quantify that? So if let's say you need to emit more carbon, what should you do? You have to buy from other people the credit. You have to pay money to buy. So to buy, so that you are you are authorized to emit more carbon or wastage. So it become it create an ecosystem where it become a kind of your credit can be traded. You can sell your excessive credit that you earn, and you can sell to other people. That is the whole idea of how the policy or the regulation is set, so that those people who emit less carbon, they will earn the credit. Then the credit they can sell. So that the whole idea is like that. Okay, let's move on from here. So how to quantify the carbon, the emission of carbon? Actually, that relates to the GH, the what you call greenhouse gas lah. Yeah, greenhouse gas. So greenhouse gas basically is those carbon dioxide lah. So for the CO2, they will quantify them by 1 metric ton. 1,000 kilogram lah. 1,000. So actually, in this here, 1,000 kilogram, the best way to quantify that, or to imagine or to realize that 1,000 kilogram or 1 metric ton carbon dioxide is by a car lah, the car you drive. So normally, if you are driving a car, 1 year you are producing about 5 metric ton.
1 year, 5 metric ton.
Okay, 5 metric ton. So that is you yourself produce. I also produce. So many people is producing. Okay, so so from there, what you can have is so you see when you produce so much carbon dioxide, there must be someone in this case, the tree, the planted tree, or the plant, or the greeneries, all those forests, they will absorb the carbon dioxide. So to realize the quantity of the carbon dioxide is one matured tree will absorb 22 kg of carbon dioxide, roughly. So in order for you to compensate whatever CO2 that you are emitting, so they need almost 50 trees to absorb 1 metric ton of carbon dioxide. So you have to 5 metric ton, and that means you have many trees.
Yeah.
You need many trees to compensate. So that is how you can realize, the 1 metric ton. From 1 metric ton, then you can see, this how this carbon credit is being set or being positioned, for them to do a trading. That will become a more what you call more meaningful figures that allow them to trade lah. Yeah. So that is one thing. So okay, next. So after knowing this, how you quantify the carbon dioxide, and then what are the things that you are you are emitting, and how to compensate that. So they in some of the country, who are the countries who actually practice this carbon credit for now? You can see from the chart there, EU is one of them. EU, America, China, Canada, Australia, Korea, and India. Those are the top lists lah. Yeah. So of course the other country all have to come. Why is this carbon credit is more important? What do you think, Abdul? Why carbon credit is so important?
Why it's so important? I think the first one is for the environment.
Yeah, it's a climate change, because the everybody is talking about. They are very scared about. We are very scared, not they are. Everybody here on the earth, because this earth is not only yours. It belongs to every of the creatures, not only human being. The animal also own this earth. So so how can you prevent the climate change? By because we know that the climate change is very much depending on how much this kind of greenhouse effect that you are going to create. That's why they make this carbon dioxide as one of the source of how to quantify that, so that I can set a cap where everybody is taking their responsibility to do a better thing, so that they can earn more credit. This is one source of reward, one source of reward. But of course, depending on, do you think this type of thing will be successful?
But who is giving the reward?
Who is giving the reward?
Yeah.
So it's just like currency lah. It's a demand and supply. When there's a demand, there's a supply. It's kind of demand. So let's look at this. So when we move on, there is a thing called the like for example, how do you were asking about how is this carbon credit relevant in this trading, in this EU emission trading system, ETS. So they use a cap reduction. This they actually cap that to ensure long-term emission reduction. That means they give you a limit. How much you can produce. If let's say you over, then you have to pay penalty. So if I set for you this area, so you emit less, that means for that year you earn this credit. So those people who want to, this regulation is set, got penalty. That's where the value come in. You pay more, you emit more, I have to penalize you.
But this also depends on the productivity, right? When you have more productivity, of course you will emit more.
Yes, that's why they don't say you cannot emit. They set a cap. They set a cap for you, so that you can. That is a limit that you can do. Productivity, I let you do, but this productivity, you don't emit so much energy, and you don't emit so much waste, pollutant into the world. Well, that's how they set. And then of course they give you allowance for some power sector industry. Of course they cover manufacturing, power plant. These are the most pollutant generator. And then the carbon price, the carbon credit price, it will be depend on demand and supply. I mean, let's say I want to do no choice. I have to do this much, so you have to buy from people who save. So there must be a balancer. everybody must be going to the direction where to reduce the carbon. Yeah. So then that's why the price will come out lah. Demand and supply. So you want to emit more? Is it because of the productivity? Then maybe set the price is like that. A lot of people demand, then the price go higher lah, higher and higher and higher. Whether you want to pay or not. So that is a thing. So of course, company trade allowance of exchange like Europe, this is one of them lah, in European. We haven't seen this in the ASEAN country yet. I don't think so. We haven't. But I think it's going to be driven by some of the stock exchange thing lah. It can become a commodity like that. The carbon can become a commodity. So the effect, what is the effect? Okay, the end effect is, the main thing is we need to encourage industry to emit less pollutant. That's very first thing. Yeah. So the other part is what is the benefit of this thing? Okay. So of course, this platform will allow you to have a more cost effectiveness way of exchange. So everybody will be motivated to produce less pollutant. That's one thing lah. So yeah, this is one of the encourage investment in cleaner technologies. That's where the topic about today. What does IoT or industrial IoT or AI is able to help you to do research? Because at the end of the day, you need to somehow quantify the pollutant being emitted. So you need what? You need sensor. You need instrument to measure. So that actually relate to the data collection, the IoT way of data collection and things like that. That will give you a figure. Then what are the things that, how do they optimize, or how do they run this one more efficiently? Yeah. So they have to use technology, like AI, to do more optimization. Yeah. I don't know. It's because of coincidence or what? These few days, when we want to talk about this topic, many of friends is asking about some related stuff like that. So in the buildings, what can you do and things like that. Let's go to the other part. Maybe Ken Long can share a little bit. Today we will talk about smart energy in the smart building. How can we do? So while we are doing this one, before we come into that, for those of you who just tuned in, you are watching the last Sembang AIoT by me, Cecily.
Yeah, and now.
So both of us, we Sembang AIoT for the past. Today is episode number 84. 83, is it?
83.
Yeah, 83. Again, 83 is also a special number. So you can ask me why 83 is so important. It's why is this special? And we welcome you to give us some input, comment and idea and things like that. You are always welcome to give us more feedback and inputs to improve some of our content here. So okay, let's move on to this smart energy, in a smart building. Okay, let's go. So Glenn, maybe you can start. Okay, before you start, I just read Yeah, I think your slide got over. Maybe we just come into a chit chat thing, while we are talking. You can talk about that. Yeah. So let's see. So AI in the smart energy management factories enhance efficiency and sustainability. Of course, I see the word sustainability. Yeah, it's part of the ESG thing.
Yes.
Sustainable. I just got to know that some of the public listed company right now, what they are going to do is under ESG, there is a KPI. There is a thing. So the KPI index for ESG. So meaning you are more ESG, higher ranking ESG, your business tends to be more sustainable.
Okay.
Your business is more sustainable. More sustainable meaning what? The investor who want to invest, they have
More confidence.
more confidence to invest in you. They actually wanted to make this one. I think this already happened. That one is, I haven't verified because I was talking to one of the ESG consultant. He mentioned to me about that thing about three days ago. That's why very funny. We were talking about this one. People will be talking to us about this thing. So that's how I share it with you. Okay, let's move on. We talk about technology, smart building, and so on. Okay, now maybe you can start up here.
Yeah. So for today, first we need to understand the importance of the smart energy management and some definition of the smart energy. So the first one is the systematic energy monitoring. So of course, when you want to monitor your energy usage or energy consumption, you must have a systematic approach, a systematic way to do this thing.
Okay.
So, and then the next one is the cost reduction. This another terms related to the smart energy management. So of course, when you do this kind of management, first thing you want to cut down your costs. So implementing this one can help you to reduce your cost, and it can significantly drive down the energy costs for the industrial operation to improve the profitability. And then the third one is the waste reduction. You want to reduce the waste. You want to and reduce the energy use. And then this one is to promoting a more sustainable operation.
Yeah. So at the end of the day, it's sustainable.
Yeah.
So if let's say I want to relate this definition of smart energy management, definitely for those who want to earn more carbon credit, they have to practice more smart energy management.
Yeah.
So that is the whole. This is how we relate lah. Okay. Let's move on.
So the last one is the sustainable goal. So by adopting the smart energy management practice, organization can contribute to their sustainability goal and environment responsibility.
Okay. So from the picture, we can see some solar plant. So solar plant considered is one of the more efficient way of using the energy.
It's a kind of green energy.
Yeah, so it won't produce any pollutant while giving you energy. That is one of them. Of course, the top one is a power plant, is it? No, the nuclear something like
nuclear plant.
nuclear plant. Okay, does nuclear plant produce waste? I think so lah.
Yeah, it produces some waste.
Does it?
If we can manage it carefully,
Okay.
if no disaster happen, I think everything should be okay.
Okay, the wind turbine producing energy, solar, and you use the EV, things like that. Okay, fair enough. Okay.
So next, we talk about what are the key components of a smart energy system. So there are three things. First one, of course, you need something for you to monitor the energy. So you have the energy monitoring tools. Then second is the automated control system. So you need something that can help you automate control your energy system. Okay. And the third one is the data analytic platform. So after you gather of this kind of data, you need a platform for you to visualize and then to perform some data analytics to see whether the current method is helping you to do some improvement or the situation is getting worse. So you need the data analytic platform. So the energy monitoring tools can help you to see. You can see, for example, the past few months, how the energy consumption trend is going up or going down. And then the automate means can automate the plan for you. For example, maybe next month you're going to reduce the brightness of the lighting by how many percent, and then for certain area that seldom got people use, then we don't automate turn on the light. We will make it become manual to turn it on. So these are some plans for help you to achieve a smart energy system.
Okay. So talking about this smart home or smart energy, because I overheard about people talking about smart home for comfortability. The building can recognize him. And go to a certain place, so he will tune the aircon to what he wants, and then But I just think a little bit deeply that is it practical? Because everybody has got their own, unless that the whole building belongs to you lah. So there's no challenge lah. But then if let's say everybody is sharing, so you want to tune to your own style of a thing, maybe just for comfortability, I think it's not practical.
Yeah, it's actually quite hard. This one, not practical.
So so that's why maybe the key component to give a guidance of most efficient way of using your energy would be more important, right?
Yeah.
Okay.
Okay, so now we talk about how the role of AI in the modern energy management. So actually what the AI can do is three things. So the first one is the predictive model. So the AI can do some energy forecasting and then optimize the supply according to the forecast result. And second is the resource allocation optimization. So AI can optimize the resource allocation by efficiently managing the energy distribution, reduce the waste, ensuring the sustainability. And then the third one is the real-time insight. So especially for now, we have the 5G technology where it can give you the real-time result. And it can, so this one allow the decision maker to respond more quickly when you have this kind of real-time data.
Okay. So speaking about this AI, of course, one of the very common practice in terms of what they call energy management is to do optimization. Optimization meaning, for example, you are most of the buildings, the most power heavy consumption are what? Those chiller, those chiller, compressor, and all the so-called hatchback kind of equipment. Yeah. So that is the most. So if let's say naturally, if let's say you want to do optimization, of course that's supposed to be area that you have to control. So I think that's another subtopic of the whole building management, because building management, they are pretty much handling this one very well. So if let's say you can see some of building, they are running PID loop. PID loop meaning they have a set line. Let's say this you want to set at 23 degrees Celsius, so that it will be fluctuating around this thing. So how they control is using the P and I, proportional and integration. That's how you do. So for this AI, meaning how would this AI know whether it's optimized or not?
Actually, how do we know whether do we need to do the optimization or not is actually depends on how we set a goal, what we want to achieve. If we set a goal, let's say we want to achieve, say that run the energy efficiency is more than 90%, but based on the current collected data, you only achieve around 60%. Then there's a room for us to do the improvement, to do the optimization. And then from there, the AI can try to figure out what are the strategy for you to do this thing.
I see.
But once we achieve it, Does it mean that we no need to do any optimization anymore?
Okay.
Yeah, and then this one is quite subjective, depends on what you want to do, what is your main objective. And then across the time, and the environment change, maybe previously you already achieved 90%, but environment change, there are other factors affecting this, it might drop. Then in this case, you might need the AI to come up another optimization plan again.
Okay. So this one actually trigger me, just trigger my mind here. You know, when sometimes I went to some of building, sometimes I feel very cold. So maybe the system is designed in such a way that every day you have to produce this much of energy to keep the space enough cooling. But if let's say a certain occasion where very less people there or something like that, so I think AI is supposed to be used in that area where less people, you don't do this one, so you run on a second mode where you can have more saving. That is more of the control of saving and this part lah. Yeah. So yeah, AI can be of course used in that manner lah. Yeah. Okay.
Yeah, so now next slide, we will talk about the AI technology in the energy management. So we move to the next one. Okay. So what we can do is we can use the energy usage pattern. So for example, we collect some historical energy usage pattern. So based on this one, the AI able to identify in your historical energy usage pattern, is there any anomaly happen or not? Yeah, because if you want to know the anomaly happen, we need to study the pattern. So when there's something happen not according to the previous pattern, that one is considered abnormal. And then based on this thing, it will contribute to the second one, the future consumption prediction. Based on the historical data and some anomaly data, so we can start to predict what are the future energy consumption. This one is another model. So based on when you have the future plan, and the factory can plan better for their future and then how to allocate their resource more efficiently to minimize the waste. And then the third one is the cost reduction strategy. So optimizing the energy use through the predictive analytics enable the factory to significantly reduce the operational costs and enhance the profitability. So this is how the AI technology is able to help you. So start with collect the data so that you can get the historical pattern and then find out the anomaly. Next, we will predict for the future. And then the third one is we can take some action plan based on what is going to predict in the future. We can do something.
Okay. So when you say the deep learning and predictive analytic meaning, so what kind of which level of deep learning that is required in this area?
What kind of deep learning?
I mean, which level of deep learning thing that AI? So of course, we usually are machine learning lah. Usually those things are machine learning.
I think machine learning is not enough already.
Yeah.
In this context, we talk about the deep learning already.
Deep learning. So meaning there are some intelligence being applied into the whole thing.
Yes.
They have to use a.
It also involves the convolution, that kind of thing, because the energy usage pattern actually is not something simple. It's not something that we can easily understand. Sometimes we need the AI to understand the pattern, especially the energy consumption of a machine.
Correct.
And then when this thing related to the big system, especially when there is multiple machine running, then the graph is become more complicated. Sometimes this machine turn on, another one turn off, then the pattern change already.
So it has to based on the historical data,
Yeah.
and then that's where deep learning come in. So you know how to get the exact thing that you want.
Yeah.
Yeah. Okay. So the IoT sensors integration, that was the thing that I was talking about, the under carbon credit. You need certain measurement tools. That's where IoT come in.
Yes.
Okay.
Yeah, of course, you want to gather this huge amount of data, you need the sensor, you need the IoT to help you to collect the data. Yeah, so the IoT can enable the real-time data collection from various sensors. So for example, from the temperature sensor, pressure sensor, carbon dioxide sensor, or even we want to know is how many people over there, we need a camera, and then in behind we use the AI to do the people counting. So all these are the real-time data collection that can help the AI to make a more accurate prediction, a more accurate decision.
Okay.
Yeah, and then it also can enhance the visibility. The integration of the IoT enhance the visibility into energy consumption pattern, help to identify the area for the improvement. So with the sensor, you know which area is not performing well. So for example, that region, there's not much people over there, but the temperature is very low. So, and then the energy usage at that region is very high. So there's the place that we need to do the improvement. And then the last one is the improved control. So the IoT integration allow for better control over the energy resource, leading to more energy, to more efficient usage and management.
Okay. So when we're speaking about these IoT sensors, right now there are more and more wireless sensors that able to fix it at certain place. Because I think building is the one that there are rooms where the optimization can be done, because different rooms has got a different pattern of usage of the energy. Yeah. So sometimes you cannot stereotype every rooms, giving this kind of power to drive that. Maybe not. That's where they can play around with more sensors that you are able to do more better optimization.
Yeah.
Okay. That's supposed to be that way. Okay.
So this one is the real-time data processing and decision making. Yeah, so with just now we talked about the IoT sensor, so we can achieve this thing. So immediate analysis, so the real-time data processing can facilitate the immediate analysis of the energy usage, allow for quick insight and adjustment, and informed decision making. So this capability empower the factory to make informed decision promptly, enhance the efficiency, reduce the waste. And last one is the optimizing the energy consumption. So actually, whatever you talk about, so at the end, what we want to do is we want to reduce the cost, improve the energy.
Yeah. So it's a smart smart energy management for better sustainability for the building. Okay. So that's why real time is a very important thing. Yeah. No problem.
Yeah.
Real time is the most important thing that.
If not real time, but things already happen for a few hours, then you only realize, then you can't reduce the waste a lot.
Okay. Let's
So
move on.
next we'll show some case study of the AI implementation in the factory. So for example, the energy optimization in the manufacturing process. Okay. So the first one is the AI-driven solution. So the factory they are leveraging the AI technology to optimize the manufacturing process, leading to the efficient energy use and reduce the waste. So they use the AI to give some suggestion on how to optimize their manufacturing process. And then the second is the energy saving. So implementing the optimization strategy can help the factory to achieve significant energy saving. This one can contribute to the sustainability effort. So, and then the third one, it's also very important, is to enhance the productivity. So the optimization of the process not only save the energy, but also enhance the overall productivity.
So that the energy is being used more, give you more values.
Yeah, you use the energy in the right place.
Right
don't
place,
waste it. You use for productivity.
More values, okay?
Okay, and another one is the predictive maintenance and the fault detection. So the AI tools can help to identify the potential equipment failure before they occur. So this one is the predictive maintenance. So actually when we can achieve this one, actually it's another way to save the energy. When your machine have some problem, it will start consume more energy. So I predict this thing early, so can prevent the faulty machine consume more energy, and then it also can reduce the downtime, the unplanned downtime. So this is how we can use the AI to do the predictive maintenance and the fault detection.
That I think predictive maintenance is more towards the application is more towards the what you call to tackle the unplanned downtime, But the efficiency of the manufacturing, let's say, how does it affect the? Okay, when we talk about 6 losses, when the energy, let's say the system is not maintained properly, normally certain things go very tight, so somehow it will consume more energy. If give you lousy cycle time, that is 6 losses that we are talking about. 6 losses talk about why the process being slow.
Yeah, the slow cycle.
Maybe when you want to do 1 minute, but now you have to do 2 minutes. That's extra energy consumption. That's why maybe not so much on, if let's say you say the manufacturing is one of the building, then that is a building lah. So we will, not only on manufacturing lah, but that is a building. So within the building, you do more efficient thing. Actually at the end of the day, is you are doing the saving lah. Yeah, you're doing the saving. Yeah. Okay.
Okay, so for this one, so at the end, what kind of benefit can achieve is the cost reduction. So implement the AI in energy management, allow the manufacturer to significantly reduce their operational costs, enhance their profitability, and then second is enhance efficiency. So AI technology improves the overall efficiency in the energy management system and leading to optimize the resource utilization and productivity. And the third one is to lower the carbon footprint. So, of course, when you use less energy, you emit less carbon.
Yeah. So talking about the manufacturing, one last thing that we want to share, because we spoke to one of the real client of us. They were using some gas energy to do some burning thing, to cure certain thing or to generate some energy. That is another source of burning. Yeah, that's another source of burning. So by looking at the process, if let's say by optimizing the efficiency of the system inside or the process inside, automatically definitely will have a saving or better improvement in terms of using the energy. Yeah, that's it's supposed to be lah. Yeah. So okay. So this is the last one, is it? Or challenging?
Yeah,
some of the challenges.
Yeah, when we want to do this thing, of course, we will face some challenge in the AI-driven energy management. So, of course, the first one, we collect a lot of data. So we have the data privacy and security concern, especially when it's something related to the camera. Of course, you are concerned Is the camera storing my face in somewhere else? So what they are going to use data with, maybe they sell my data to other third party. So of course, data privacy and security concern is one of the challenge when we want to do this thing. And then the cyber security, so there also some factory they were quite worried about this one. If let's say someone hacked into my factory, so how am I going to handle, protect the data, all the safety, sensitive information? So this is one of the challenge they face.
Yeah. Why is this challenge? Is because certain data you need to be exported outside in order to do some optimization. Yeah. So if let's say you're worried about security or you don't have a security, so you are not able to implement. So this become a challenge. Yeah, this become a challenge. Okay.
So the other, so we move. The next one is the integration with the existing system. So actually, when you want to integrate, for example, the AI system into your current existing system is another challenge, especially when your current system is proprietary one, and actually it's very hard to do this thing, and you must have the mentally preparation. You're going to change a lot of things, and this will cost you a lot. But if you think for the long term, if you start doing this thing today, actually if you are preparing for the future technology to come inside. So you need to do, it's what you call the phase implementation strategy. So you need to gradually do the integration phase by phase. So this is the second challenge we're going to face, integration with the existing system. So now we move to the next one. Yeah, this one is the skill and knowledge gap in the workforce. So your current existing worker might not know how to operate this thing. They might don't have the knowledge on what is the smart energy management, how to use the tools to achieve their goal. So we need to understand your current workforce, what are the current skills they have. So does they need to have some training to do this thing? So same as when we always talk about the Industrial Revolution 4.0, so does your worker have the mindset to do this one or not? So same thing, when you want to apply this kind of new technology into your current system, to current working environment. And yeah, the last one is the effective skill utilization. So they must have the skill to do this thing.
Okay. So of course that is the very important part. We have seen many cases like that before, where the internal team is a great importance, because without them cooperating, or without them initiate certain things, sometimes it's actually become a challenge.
Yeah.
It's can become a challenge.
You buy the system, but your staff don't know how to use it.
Okay. Okay.
Okay, so the last one is the future trend and the innovation. So we move to the last one. So this one, so recently we talked about the agentic AI, so the advancement in the agentic AI and the generative AI. So how this thing can help you to do the, for example, the predictive capability in a more accurate way, and then how they can help you to do the energy management more efficiently. So compared to the current existing AI technology, so what I think is, in the future when the agentic AI and Gen AI come in, everything it will become more automated, more easier to use. And people, just now we talk about some worker that need to have some skill to do this thing. But I think in the future, they just need to understand how this thing happen, and then they just give the instruction, maybe through the voice or through some text. They not really need to understand how the entire system works. So everything will become more simple in the future.
So meaning there are some pre-trained modeling that is driven by agentic AI.
Yes.
So that thing will do more automation within the process. So not so much. Yeah, we have gone through I think two phases of this thing because when AI you can generate the action based. Action based still require human intervention, in order to correct that part. But by having this agentic AI, this thing can be more autonomous, where you do not need human intervention, but that is driven by what? That is driven by the pre-trained model or so-called LLM or whatever, that able to drive this. So these are the two sets. Now we are in the transition of this here and here. Okay.
Yeah, you need to trust the AI able to help you first.
Okay.
Yeah, this one is the last slide.
Okay, thank you very much, 𝐷𝐚𝐲, for such a lengthy and interesting sharing about each and every one of the point. So I hope you are not bored by this thing, but these are all key points. In order to end this, just want to share with you. Of course, me and 𝐷𝐚𝐲, we are doing some AIoT, AI and IoT hands-on classes. Yeah. So let's say you are interested to know more about that. Those are very fundamental, but it's hands-on. You do not require any coding experience. You don't need to know programming, doesn't matter. In order to realize that, to have a hands-on, to help you in the industry, to help you in your company, to help you in a future career, or to help you to improve even a smart building. You were in the building, how can you do that? Of course, that is also possible. But we are more tailor-made to more manufacturing thing, IR4 related on AI and IoT. That is one part. But we do have a different set of tool set, from very low-level sensors, and also controllers, gateways, whether wired or wireless, and also AI, edge AI stuff, that you can train model. And we have some software tools as well, software tools that help you to build those AI model, and you can do AI modeling yourself. And finally, that can you bring to the application. We do have a cloud related solutions for you to work on for your process. Those are all available. So if you have any project at all, or if you have any idea, would like to put that onto ground to work, maybe, no obligation, you can always talk to us. So with that, I think we want to sum the whole session today. So again, thank you very much for watching. If you feel this channel is right for some of your colleagues, do share with them. So if you think this give you some insight, do give us a like. So of course, we would like you to subscribe to our channel so that you can follow some of the next coming sharing. Okay, with that, see you and happy weekend to you. Bye bye.
Bye-bye.